Welcome back everyone. To compare photodiode and solar cell, I have made a comparison versus video. As you can see that it got a little messed up. I felt like that the photodiodes are something like this, LEDs are something like this, and solar cells are something like this. So to understand with the clarity, I made two simple diagrams. So let's now understand that. So here is the sun and the photons are coming. The story are pretty much the same. The figure clarity is important so that you can put the same figures in your examination or anywhere else to understand or make other people understand what you have learned actually. Okay, so let's begin with this. So the light is the form of energy, and this is the formula of the energy, the Planck's energy, as you have remembered in your earlier lessons. So this is the form of the energy. The UV rays are coming and falling on the depletion region. It disturbs the depletion region, and when it depletion region gets disturbed, you can see that we have a source here. We have a power source here, and you can interestingly see that it is reversed biased, and there is also a resistance, and we can see the change in current, which is quite obvious because there should be flow at least in one direction. So it is attracting, so the flow is quite pretty much obvious, and it is going through the resistance. Now let's ponder for solar cells for a while. In the same case, Pn, it is going to fall upon the depletion region because this is the most vulnerable region that you have to disturb the equilibrium, and it starts the flow. So as you can see, the P is losing and traveling the holes, or you can say the electron is traveling from these path to this one, and all that thing is happening, but there is no power source. So there is a power source and there is not any power source. So can you tell me that why there is no power source? Well, the answer is quite pretty much simple. It's in its name. It is the cell itself. So what is this resistance? This resistance is actually our load resistance. It means you can plug in a bulb here and it will get lighted up. So this is the concept here. And what is this one? You are having a reverse bias. You are proportionality of the intensity is coming out. It seems quite pretty much similar, but just think once that if we are providing the power, so can we extract the power? Maybe, but we do not intend to, because we have solar cells already with a similar concept. We have the resistance, that is actually the load resistance, but in this case we provide the power to store and check the intensity. So it is a meter to check. That's why in the common languages or common culture it is not pretty much famous. The photodiodes are not pretty much famous. I'm not talking about the science or technology industries, or talking about the other such things. I'm talking about the solar cell popularity is quite rocket high. It is not that high, it is a little high. So that is a comparison, because we are providing power, so we need some power to push it to a limit, and then we absorb the photons here, and when we absorb the photons we get to know that what is actually going to happen, and in this case we do not have something like that. So this is the diagram that you can use. So I have answered the first question, and I'm going to answer the second question, that why we are using the n side on the topmost layer in the next one. So stick with me, take care, God bless.